Hey there, sixth graders. In this video, we're going to go through and do a little bit of class notes for our new unit on energy. And then we're going to go through and talk about what it is that you're going to finish and accomplish during class when I'm not there today. So let's dive right in. The first thing we're going to do is just do a slide of notes. So to be able to do this, if you haven't grabbed your science binder, you're going to need to pause the video and go get your science binder because you need your flip chart that we made in class yesterday. So pause the video if you need to do that now. All right. Those of you that were not here yesterday, I made a flip chart for you. It is up on my desk. If you need to go ahead and grab one, I put your name on it, so you'll have it up there. All right. On your flip chart, and I forgot to bring one of the examples home with me, so I don't have one here to show you. But on the flip chart, the very top flap, if you wrote down the headings for all the different flaps yesterday, the top one says forms of energy. And that's where we're going to go. We're going to just do one basic general slide about energy. And then as we go through the unit, we'll use this flip chart to go through and talk about the 7 different forms of energy. But today we're just going to kind of talk in generalities and we're going to do forms of energy. So go ahead and flip up that very first flap. And remember, like I showed you yesterday, when you flip the flap, sounds funny to say every time. When you flip the flap, you're going to start at the top of it. Okay. So you're going to use the underside, and you have all that room to where you then drew a line of where your flap ends. That's the stop line, so that any of your notes, we don't want those to come onto your cover art. So that line is there to tell you, okay, that's as far as I can go. There's only one slide for this, so there's plenty of room. Okay, but I would probably get in the habit for this of just writing at a normal size. So if you normally write big with your handwriting, see if you can write just a little bit smaller as you go through this. Otherwise, there might be some of these flaps where you are pushing the edge for room to write. All right. All right, so let's go ahead and get in here. Let me shrink myself. There we go. So I'm out of the way. Okay. So go ahead and write this little subheading here, energy, up to the top left corner on the underside of your flap. And like I said, we just have one slide here. All right, the definition of energy. Definition of energy is that it is the ability to do work or cause change. The ability to do work or cause change. All right, I think cause change is pretty self-explanatory. To do work. In science, work actually has a definition, a very specific definition. Okay. And that when work is being done, that means literally there is a change either in the object itself, meaning like it changes forms. So, like wood burns and changes into smoke and ash, or something has moved, right? It has changed position. That's work. Okay. And the ability to do that is because of energy. All right. 2 basic types of energy that are kind of like the overarching umbrella that all of these forms of energy that you wrote down on this flip chart fall under. And it's potential and kinetic. As we did the ball balance lab this week, it's easy to hear from your guys' conversations and things. These are terms that you're somewhat familiar with because of studying energy a little bit and different forms of energy in elementary school, whether it be in 5th grade or 4th grade. So all the forms that we talk about here in the next week or two always are going to fall under being either potential or kinetic. So let's start with potential. Potential energy, or PE for the easy abbreviation, is energy due to position. We're going to spend the first couple days here in this unit just focusing on potential and kinetic energy, like with your energy skate park lab, like we did with the ball bounce lab. The Ed puzzle that if you get to today, but is due next Friday, that is all about potential and kinetic energy too. All right. So PE was a sub bullet. This is a sub bullet. And this is a type of potential energy, gravitational potential energy. Gravitational PE is affected by mass and height. Gravitational potential energy is the specific type of potential energy we were observing when we did the ball bounce lab. We talked about height for sure. We even graphed how height affected it as one of the variables. When we discussed the results of our ball bounce lab yesterday in class, we began to talk a little bit about mass, but not really a lot in terms of the specifics of it. And so you will it in one of the activities today as we go through here as well. I do want to point out with potential energy that oftentimes you're going to hear it referred to as energy that is stored. And while that is a great way to kind of remember what it is and and how to think about it, that's not technically what's happening. The energy isn't in there just stored. It's there because of its position, okay? If it was just stored energy, then technically it would just always be in there from the moment that object was created or made, right? And that's not how it works. But it's good to kind of it's an easy way to remember that's what potential energy is, that it's there and there's the potential for this energy to change and be released. Um, but it's not technically just stored in there. It's not waiting to be used. All right, kinetic energy then is what we focused on a lot with our ball bounce lab, and that's the energy of motion. So as the ball falls, there's motion. That means it has kinetic energy. Even when it's bouncing and bouncing up, there's some kinetic energy there. As you're going to see with the energy skate park lab, potential energy and kinetic energy can change back and forth into each other. And it doesn't necessarily mean if it has one of them, if it has potential, then it can't have kinetic. That's not necessarily true. They can be increasing and decreasing at the same time. So they can have some of both. For us in this unit, it's going to be really important to recognize not just if it has potential or kinetic energy, but it's also going to be important for us to recognize, well, in this situation, in this position, in this scenario, is the object gaining potential energy and kinetic energy? Is one of them staying the same? Are they decreasing? Are they increasing on one and decreasing on the other? That's going to be important to recognize because not every situation is it just all potential energy or all kinetic energy. And so we'll be focusing on that with the energy skate park lab. Okay, another sub bullet here. Two variables or two factors that are going to affect kinetic energy are again mass. And then this one, the other one is speed, velocity. Okay. I'm not going to get too much into that right now. You're going to do that with the reading guide. We're going to end up doing that a little bit more as we get to Energy Skate Park 2 and some of the other things we do in class. But those factors we're writing them down because you do need to know. Okay. Those are just very important. You need to know that potential energy, specifically gravitational potential energy, is affected by mass and height, those two factors. And you need to know that kinetic energy is affected by mass and velocity, those two factors. That is really important for this unit. That's a big idea that we need to know. Okay, last bullet here. Energy comes in 7 forms, all of them a little different from each other. They're all energy, right? That's why they're in this unit. That's why they're on this flip chart, but they're all a little bit different from each other. So we're going to focus more so on the differences than how they're alike. We're also going to stay at a very foundational or basic level of these energy forms. We're not getting into them very deep. In fact, almost every single one of these you could literally have in a complete unit on the energy. And some elementary school units were complete units. You might have done sound, you might have done light energy. We're just going to be very surface level with these. And one of the big things you're going to do, and if you need to go pause the video to go back to make sure to copy that and go ahead. But one of the things that we're going to do in this video, and you do not need to write this down. I repeat, do not write this down. This is going to kind of be a good test to make sure that you guys aren't fast forwarding through the video and ignoring me and just writing down what's up on the board. Because if you write this down on your flip chart, then I know that you weren't really listening to me. So this will be a good test. All right. So what we're going to do in this unit when we get to these 7 forms of energy is you're going to basically just need to know definition, and then you're going to need to know examples. The examples of the energy in everyday life are going to be the way that you can demonstrate to me that you understand the basics of what this form of energy is. So for instance, what I mean by that is, I might need to move myself here. Yeah. I'm always going to be asking you for examples. I'm going to give you some examples in class. I'm going to make you come up with some of your own examples in class. But every time we do use examples, when we're giving examples, like it says here on the slide, you're going to have to be specific. And what I mean by that is you're going to always have to answer the question why, or how do you know, to be able to get full credit, because that's going to be the way that I know you understand the material. Okay. So if we're talking about electromagnetic energy, which is light energy, you could say that an example is a light bulb. And I would be like, okay, that makes sense. But you're going to have to explain, how is that light bulb a good example? Or why is that a good example of electromagnetic energy? And so it would just be a simple explanation. A light bulb is an example of electromagnetic energy because it produces visible light. Done. Okay. But that's a great, easy example of what it is that you're going to have to do repeatedly in this unit. Give an example from everyday life and explain how that example is a good example of that energy form. Okay. At this point, we're not going to take any more notes. Okay. You were not writing anything down on this slide. Now we're going to transition. Make sure you put the flip chart into your science binder, into that pocket, so you do not lose it. We cannot lose those. Okay, put that in there. And here's what we're going to do for the rest of the time today. Okay, very first priority after these notes are if you need to finish Energy Skate Park number 1. Some of you are done, some of you are not. That has to be done first. That is independent work. So if you started it in class on Wednesday, I made you work on it by yourself. That continues today. You have to finish that one by yourself. When you're done with the Energy Skate Park number 1, there is a reading guide posted in Google Classroom. That reading guide has a doc that has the answers, or I shouldn't say the answers, has the questions for you to answer. The reading is a handout that I have up on my table. That handout is not for you to keep. When you are done or when class is over, you have to put it back on my table, please. I do not have copies for everyone made today. They are just class sets. So you are not keeping that reading, but you can use that reading to answer the questions and fill in the blanks on the reading guide. Like it says on the doc, make sure you're also looking at the pictures on that reading guide and the explanations of those pictures, because those are examples and those are great ways for us to understand and learn about the content. So some of the answers are going to be in the pictures. So pay attention to that. You are allowed to work with somebody with the reading guide as long as they're done with Energy Skate Park as well. When you're done with the reading guide, if there is still any time remaining in class, there is an ed puzzle posted about potential kinetic energy. You can begin to work on that. That would be individual work, obviously. That, though, is not going to be due all the way until next Friday, a week from today. It's next week's homework, but I put it on there just in case some people get to it today, so you have something else to work on. That's mine. Might as well knock it out so you don't have to worry about it. All right, so make sure you're getting through and doing your work today. Be on task. Okay, do not get distracted from your classmates as well as your computer. Okay, making sure that you're staying and doing what you're supposed to be doing and using your time wisely. And I will See you guys on Tuesday. Have a great long weekend. All right. Bye.